welcome to the lecture on Introduction to Economic Equivalence. So, we discussed about many types of interest factors. Then we also discussed about the compounding frequency of interest. Now, many a times you need to know, you have a cash flow where many transactions are taking place, and then you have transactions taking place at different times in different quantity, and also it may so happen that at some point of time between certain periods the interest rate also may vary. So basically at that time, how to tackle these transactions which are taking place, what will be its effect cumulatively if you try to compare with certain other type of cash flow or alternatives, because many a times you need to have an understanding of the situation, what way you will be benefited by the offers. Suppose there are two banks and they are giving you two types of offers, or a bank itself is giving you two offer. In that case, how to compare these situations? For that you will have to understand things. You have to see the transactions, you have to see the cash flows, you have to add or subtract, take into account the interests which are taking place, interest rates which are there in certain period or so. So for studying these things you need to have the understanding of the equivalence, economic equivalence, and we will have some introduction about this equivalence and also some concept about it in this lecture. So two things are said to be equivalent when they produce the same effect. So when they are producing the same effect, you tell that they are equivalent, in the sense that if you are two cash flows, if both the cash flows are giving you same return, or in fact both are yielding same future value or same present worth, something like that, or same annual equivalent value, all that. So in that case you can say that they are basically equivalent. Now for comparing two different situations, the parameters to be evaluated must be placed on an equivalent basis. So basically you will have to place, or you have to evaluate the parameters on an equivalent basis. Like if your you have two cash flows, and then if you have to compare them, then there are certain parameters like what is the how much is the transaction going on, or when the occurrence is there, what type or what time these transactions take place, what is the interest rate, all these things they must be placed on equivalent basis. Many a times what happens that if one will affect will be changing, other will change. So suppose what way we can understand this, that for finding equivalence in engineering economic calculations, the elements involved are amount of sums, times of occurrence of the sums, and interest rate. So basically when we talk about analysis of the system, financial transactions or so, in those cases basically you have three elements involved. One is the amount of sum. So how much is the transaction, what is the amount of transaction which is taking place, then what is the times of occurrence of it, when it is taking place. Some of the receipts may be at the second, fourth or fifth time, and some may occur even at fourth, eighth or 10th time. So that time of occurrence is also important. And then the interest rate. So that interest rate also is to be seen, that what is the interest rate. Many times you need to find the interest rate which will make something equivalent. So what will be the interest rate, suppose which will make today's 1000 rupees equivalent to 1500 after 10 years. So that way, that time you need to have the interest rate. So if the interest rate will be varying for different interest rate, they will have different value of F or P or so. So what we mean to say that out of these three, if you are basically fixing 2, so third will be fixed basically, and if you are fixing 1, so 1, by changing 1 you can even change the second, so that you will get the equivalent value, or the cash flows will be equivalent. So such is such cases we have to see that how you will see that how this equivalent concept or equivalence concept you will be tackling with. Now what you can say that suppose you are given two options of getting a reward from your organization. Now let us say the option 1 is that the organization is telling you that you will get rupees 50,000 now, and in the second option you are told that you will be getting rupees 8,000 per year for next 10 years, and that 8,000 rupees will be given to you at the first year end, and then further 8,000 second year end, and so it will be given 8,000 rupees for the next 10 years. And the rate of interest you can have it equivalent to 12%, because you have taken a bank loan and for that it's 12%, so you can take that as the criteria for the interest rate. Now if you are told to decide that which one should we prefer, if by looking at cursory, if you look at one point, what you see that you are getting 8,000 for 10 years, so it will be 80,000 something like, but you are getting only 50,000 now. So the thing is that what to decide, which one will be better, better deal. So for that you must understand that what will be the equivalent value. So for this you need to calculate the equivalent value. Now how to calculate that equivalent value? So if you try to see that you have two situations. One is that you are getting 50,000 now. Another is that so your p value is coming as 50,000. In this case, in the another case, so what is coming is you are getting 8,000 rupees every year. So your 8,000 is coming every year, and you are going up to 10 years. So 1, 2, 3, and then it will go to 10. Now if you have to compare these two, you will have to have the equivalent value of this at the time t(n) equal to 0. So what you do is that you get the equivalent value, and for that what you do, and your I is 12% compounded annually. So for finding that equivalent value, what you will do is that you will get the present worth, and for that, and this is A is given, so you will multiply 8,000 with P by A, and then R and or I you can say, and N is 10, and this I is 12, so it will be 12. So P by A 12, 10. Now P by A 12, 10 factor is to be found out, and if you try to see the factor value of this P by A 12, 8. So this P by A 12, this is 12% and 8th this time. So I think it is for 10 years, not 8 years, it is for 10 years. P by 8 12 10. So P by A 12 and 10, and in the 10 it comes here. P by A 12 10 is 5.65. So this P by 8 12 10 is 5.65. So if you multiply that, it will be 45,200 rupees. Now you can compare, because if while comparing you must have the equivalent basis, and you have to compare the these two amounts at a particular time, and the present time you are comparing, and it is coming as the present value is coming as 45,200. Now, it will be easy for you to compare these two situations, and you can very well say that the offer which you are getting, the option 1, where 50,000 you are offered now, that is more advantageous, or it will give you more profit, I mean, as compared to the option 2, where you are getting 8,000 rupees for the next 10 years. So, this way these principle of equivalence is to be utilized, and you have to find these equivalent values for all these cases, and then you have to decide what should be done. Now, when finding these equivalence, you may have a single factor which is involved, and at that time you have to understand how to proceed. So, you may have the equivalence calculation involving single factor. So, what happens that you must have we have already discussed about the different factors like P by FIN or F by PIN, or F by AIN, A by FIN, all that we have studied. And here what we will see that you have a single factor which is required to be known, which will tell us that whether they are, what will be that value which will make this equivalent. So, in those cases that single factor is required to be known, and in that case for example, suppose you have the F by P IN factor calculation is there. So, we know that this is the factor which is known as single payment compound amount factor. Now, what may happen that you are given some future amount and present amount, and you may be told, or you are given time period, interest rate, and a present amount, and you may be told to find the future amount. So, in that case you have to calculate these values accordingly. For example, suppose let us say that compound amount on April 1, 2010 is equivalent to principal amount of rupees 2000 on April 1, 2002. Now, an interest rate is 9% compounded annually. So, in that case, if you are required to calculate the values that what will be the compound amount, equivalent compound amount. Now, in this case, as you see that your n becomes equal to, so you have 8 years of time span in between. So, you have n as 8, IV is 9%. So, ultimately you are going to have the F as P, and then you will have a factor F by PIN. So, this present amount was 2000, and if for the 9% we will refer the 9% table, and if you refer the 9% table, F by P and 98, if you see this value, that value will be something close to 1.993, and P is given as 2000. So, now if you multiply that, it will be rupees 3986. So, now this is this is the amount which will be equivalent to the present amount of principal sum of 2000 on April 1, 2002. Now this may change, this amount of f. So this f amount will change if the one of these factors are changed like I or n. So suppose your interest rate is changed and you are told to find that if the interest is compounded continuously in that case. Now if the interest is compounded continuously, in that case the same factor, so this factor will become 2.054 in case of continuous compounding. So if you do that, it will be something like 4108. So this amount will be 4108 rupees for the case of continuous compounding. So the thing is that if these things are changed, in that case the value will change, and then we can say that under the condition of continuous compounding of interest, the rupees 2000 on April 1, 2002 is equivalent to rupees 4108 on April 1, 2010. So that way you will have the one factor calculation in the case of these equivalence value calculations. Similarly, you may be given the future value and the present value or principal sum, and also you are given the time, but you are told to calculate I. So in those cases you have to calculate the rate of interest, and you can have one example. Suppose you have number of years is known, and and then so P and F is known. So P is rupees 300 and F is rupees 525, and number of years is 5. Suppose now what rate of interest will make this principal sum of rupees 300, present value of 300 rupees, equivalent to rupees 525 in 5 years. So here the concept of equivalence will be used, and what you know that F equal to P into F by P and I, and N is 5. So now you have F by P I 5, basically we know that it is 1 plus I raised to the power 5. So based on that you can have this calculation, and you can find the value accordingly. So this this value can be calculated, and also from by looking at the interest table also you can find it. Now so similarly as we told that sometimes you may also be required to find the time. So the time again further can be calculated, and whatever parameter is required to be understood or calculated, that can be found out using this principle of equivalence. So even for other factors also you can use the same thing. The equations will only be going more and more complex. In case of F by P or P by F, it is somewhat more simple, but that equation, suppose we are taking for P by A or A by PIN, in those cases it will be more complex. In that case, many a times you may need to go for hit and trial methods, or you have to go for interpolation. So by using the interpolation you can find these values. Now what we further try to understand is that when in most of the financial transactions, when we talk about, we deal with the transactions which are taking place with time, and then ultimately you will have to find the equivalent values at a particular time. So in fact we are trying to see that how in the case of cash flows, how this principle of equivalence works. So we will be dealing with equivalence involving cash flows. Now, this we can understand by taking an example. Suppose you have to find the present, to find the present amount, equivalent amount basically, and the cash flow is going like this, that you have 300 rupees 300, end of year 6, and rupees 60 end of years 9, 10, 11 and 12, and suppose rupees 210 end of year 13, and rupees 80 is end of year 15, 16 and 17. And the interest rate is basically shown as 12% compounded annually. Now, what we see that these are the transactions. You have 17 years of time domain. In that you have only rupees 300 is transacted at the end of year 6, and from rupees 60 you have years 9, 10, 11 and 12, then 2, 10, 13 and 80 is 15, 16 and 17. So, what will be the equivalent present amount for such cash flows? So, we have to analyze such cash flows, and then finding the equivalent. So, the aim is that for all these transactions, you have to have its equivalent value to be defined at time 0. So, if you try to further see, before that we must understand certain principles, certain rules what we deal with. So, when you are earning the interest basically, then any transaction which is occurring at one point of time, there may be you are getting the equivalent at certain value. Suppose you have many transactions going on at different points of time. Now, the thing is that if you are finding suppose this is also one transaction. So, if you have to add this and this, in that case either its equivalent is to be found here or its equivalent is to be found here. Then only if they are occurring, if you are finding its equivalent at a particular time, then only you can add or subtract them. So, basically when interest is earned, amounts can be directly added only if they occur at same point in time. So, at same point in time, suppose in that case there could have been one transaction here. In that case you can write that there will be net either receipt or disbursement, but otherwise if you have to add them or subtract them, you will have to bring them at a common point of time. Now, what we see that here these things are occurring at different times. How to see solve such cases. So, what you can do is you can have the time. So, this will be your end of year, and you can have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and 17. That is what you have 17 years in which that transactions are taking place. You know that in the 6th year end you have rupees 300 taking place. So, this is coming as 300 here. Then in the in the 9, 10, 11 and 12 rupees 60 is going on. So, in the 9, 10, 11, 12, 9, 10, 11 and 12 rupees 60 is transacted. Then you have rupees 210 at the end of year 13. So, at the end of year 13 it is rupees 210, and then you have the at 15, 16 and 17 you have 80 rupees. So, this is 80, 80 and 80. So, the thing is that when you want to find the present equivalent value, you will have to have the equivalent values of all these at time 0. So, how to have that? So, you will have the partially you will calculate its present value calculation. Now, if you try to find the partial value of the present value calculation of this amount, now this amount will be multiplied with a factor, because this is a future value at the end of 6th time period. So, you will multiply this with the factor p by f I n, and I is we know that 12%. So, you will multiply with p by f 12 6. So, you are going to multiply this, its value will be 300 multiplied by p by f and 12 and 6. And if you look at the factor table, then p by f 12 6 it will be 0.5066. So, in that case you will multiply this with 0.5066, and this value will come out to be 151.98. So, this will be 151.98. Now, you will go to the next set of transactions. Now, these 4 transactions. Now, we know that now in this case what happens that you are if you try to get, now what you can do is that for all this they individually can be mapped for the year 0. So, 60 will be multiplied with p by f factor 12 9, again 12 10, 12 11, 12 12, but that will be that is not the proper way. Basically, you know that these are all the equal values. So, basically you can use the that annuity concept formula. Now, what you can say that for these 4, if you apply the p by a formula, p by a is defined 1 point here ahead. So, if you take p by a 12 4 and multiply with that, so that will be defined at time 8, and then again you have to multiply with p by f 12 4. So, what you do is that you multiply this rupees 60 with p by a and 12 4. So, this will be defined at this point, and further to define it at this point you will again multiply this with p by f and 12, and this is at 8. So, p by f 12 8. So, if you see that p by a 12 4, if you see p by a and 12 and 4, this factor is 3.0373 or 774. So, you multiply that with 3.0374, and then you have p by f 12 8. So, p by f 12 8, again you can see p by f 12 8 will be 0.40388. So, it will be 0.4039. So, if you now this amount basically will be, so basically this amount is defined here. Similarly, this amount which is coming out to be 73.61, and this is basically defined at this point. So, you are getting the equivalent value of these 4 values at this point. Now, again this 210, it is occurring discretely at time 13. So, for this you 210 is to be multiplied with p by f, and this will be 12 13. So, p by f 12 13 is you can further see p by f, and 12 and 13 it will be 0.2291. So, you can have this factor as, and then you have the 0.22917. So, 0.2292 you can write. So, it will be 0.2292. So, this value will be coming out to be rupees 48.13. So, this value will again go here. This is again its equivalent is found at time 0. Then for these 3 values, again you have to calculate, and now in this basically we can get p by a, and then we can calculate by p by f, or you can get f by a. So, f by a, so 80 will be multiplied with f by a, and it is out on 3 times. So, it will be f by a 12 3. So, it is defined at time 17, then you can have p by f 12 17. So, this if you refer to the table, it will be 3.374, and this will be 0.1457. So, it will be coming as rupees 39.33, and this is again at this point. So, basically you are going to add these 4 values, and it will give you the value which is coming out, you can add them, and it is coming as around rupees 313.05. So, this is the present value, equivalent value of the particular cash flow. So, that is how we try to deal with the cases of cash flow in the case of the finding the equivalent values, and this will be useful for many cases when we deal with problems of such type in the long run. Thank you very much.